Hello. Hi everyone. Hope that everyone are fine and everyone has enjoyed my previous lectures on CCNA. So today's lecture is on protocols and models. I'm going to share the slides. So protocols and models. What is basically a protocol is a protocol is nothing but a set of rules and regulations that guides the network. And models, there are different models are there like OSA reference model, TCP/IP reference model. These models helps the network for data communication purpose. So what is the module objective? So this module title is protocols and models. Objective is explain how network protocol enable devices to access local and remote network resources. The rules describe the type of rules that are necessary to successfully communicate. Protocols explain why protocols are necessary in network communication. Protocol suites explain the purpose of adding a protocol suite. Standards organization explain the role of standards organization in establishing protocols for network interoperability. Reference models, as I told, explain how the TCP/IP model and OSA reference model are used to facilitate standardization in communication process. Data encapsulation is nothing but it allows data to be transported across the network. Data access explain how local access local host access local networks on network. Design a communication system. Our objective is to explain the role of protocols and standard organization in facilitating interoperability in network communications. The rules. In network communication fundamental, there are three elements are there. One is source, sender, another one the destination, another channel, media that provides the path of communications to occur. Communication protocols. All communication are governed by protocols. Protocols are the set of rules that communications will follow. These rules will vary depending on the protocol. Message, signal, transmission medium, signal, message. So message source, transmitter, transmission medium, receiver, message destination. So message, signal, transmission medium, signal, message, message source, transmitter, transmission medium, receiver, message destination. So how the message is going? It is showing. Rule establishment. Individual must be established rules or agreements to govern the conversation. The final message is difficult to read because it is not formatted properly. The second shows the message properly formatted. Like humans, communication between governed rules, it is very difficult to understand messages that are not correctly formatted and do not follow the established rules and protocols. Like rules govern communication between humans, it is very difficult to understand messages that are not correctly formatted and don't follow the established rules and protocols. The first one is message difficult to read because it is not properly formatted. Like human communication between governed rules, it is very difficult. It is two different words, but it is here. It is single word. To understand two different words, it is single word. Messages that are not correctly formatted and don't is two different words. It is single word. Like that, some many errors are there which need to be overcome, and these errors are overcome in the second paragraph. Rule establishment. Protocol must account the following requirements: an identified sender and receiver, common language and grammar, speed and timing of delivery, confirmation of acknowledgement requirements. Network protocol requirements. Common computer protocol must be in arrangement and include the following requirements: message encoding, message formatting and encapsulation, message size, message timing, message delivery options. So these are the points. Network protocol requirement. Encoding is the process through which we encode. There are different various encoding techniques are there. RSA, CSA, different advanced level encoding techniques also there. Message formatting and encapsulation, message size, timing, delivery options. Message encoding. Encoding is the process of converting information into another acceptable form for transmission. Decoding is the reverse process of encoding, which processes the interpret the information. So basically, encoding is the process of converting information into another acceptable format, means which can be accepted. But in case of decoding, what we are doing, the reverse process of encoding, and we are decoding the message to its original form. Message formatting and encapsulation. So when a message is sent, it must use a specific format or structure. Message formats depend on the type of message and the channel that is used to deliver the message. So here it is showing version, traffic class, flow level, payload length, next header, hop limit, source IP address, destination IP address. IP address is 32 bits. This is also 32 bits. This is message formatting and encapsulation purpose. This diagram is being represents. Message size. Encoding between hosts must be in an appropriate format for the medium. Messages sent across the network are converted to bits. The bits are encoded into pattern of light, sound, and electrical impulses. Destination host must decode the signal to interpret the message. The message size, nothing but messages sent across the network are converted into bits. First point. These bits are encoded into a pattern of light or sound or electrical impulses. And at the end, the destination host must decode the message by using the decoding process to interpret the message. Message timing. So message timing consists of flow control, response, timeout, access method. Flow control means, suppose my capacity is to tell 100 words per minute, and suppose the receiver or the listener capacity is to receive 50 words per minute, then definitely 50 words will be dropped. So this is the flow control mechanism which manages the rate of data transmission and defines how much information can be sent and the speed at which it can be delivered. That means it manages the rate of data transmission, how the data speed will depend upon, and defines how much information can be sent, how much data can be sent, and speed at which it can be delivered. Response timeout manages how long a device waits when it does not hear a reply from the destination. Access method determines when someone can send a message. There may be various rules governing issues like collisions, like collision CSMA, CSMA CD, collision CSMA, collision detection method. These are two collision detection methods: collision avoidance and collision detection. Some protocols are proactive and attempt to prevent collisions. Other protocols are reactive and establish a recovery method after a collision occurs. Message delivery options. Message delivery may one of the following methods: unicast, multicast, broadcast. Unicast is one-to-one communication. This is unicast, one-to-one communication. Multicast is this is one system to another system communication is going on. One system to many system communication is going on. That then it is multicast. Broadcast is one to many, one to all computers, all PCs are connected here. It is going message. Note there is important point is here. Broadcasts are used in IPv4 networks, but are not an option for IPv6 networks. Later we will also see Anycast as an additional delivery option for IPv6. Note about the node icon. This is the node icon. Unicast, multicast, broadcast. It is showing how these figures are illustrating how the unicast, multicast, broadcast actions take place. Protocols. As I said previously, protocols are nothing but the set of rules and regulations that guides the networks. Network protocol overview. Network protocol define a common set of rules like network communications, network security, routing, service discovery. Network communication enable two or more devices to communicate over one or more networks. Network security secure data to provide authentication, data integrity, data encryption. Routing enable router to exchange route information, compare path information, and select best path. Using any of the best path, we can use minimum spanning tree or Dijkstra algorithm or Bellman-Ford algorithm. Any one of the method we can use to find out the best path. Service discovery used for automatic detection of devices or services. So protocols can be implemented on devices like software, hardware, or both. Protocols have their own function, format, rules. Network protocol functions. Device use agreed upon protocol to communicate. Protocol may have one or more functions like addressing, identify sender and receiver. Reliability provides guaranteed delivery. Flow control ensures data flows at an efficient rate. Sequencing uniquely labels each transmitted segment of data. Error detection determines if the data become corrupted during transmission. Application interference, process to process communication between network applications. So functions, these are the functions: addressing, reliability, flow control, sequencing, error detection, application interference. Like this is a network where I will send the message across the network using IP4 header. Next, I can forward this message because I understand the IP4 header. I can accept this message because I understand IP4. This is the server is saying. This is the router is saying. This is the sender is sending this message. So devices use agreed upon protocol to communicate. Protocol may have more than one functions, which I described below. Protocol interaction. Networks require the use of several protocols. Each protocol has its own function and format. Like HTTP, TCP, IP, Ethernet. HTTP stands for Hypertext Transfer Protocol. It governs a way a web server and web client interact. Define content and format. TCP, Transmission Control Protocol. It manages the individual conversations. It provides guaranteed delivery. It also manages flow control. As I told previously, what is flow control? It is very important in computer networking, flow control. Internet protocol, IP, delivers message globally from the sender to receiver. Ethernet deliver message from NIC to another NIC on the same Ethernet local area network. Protocol suites. Network protocol suites. Protocol must be able to work with other protocols. Protocol suite, a group of interrelated protocols necessary to perform a communication functions, sets of rules that work together to help solve a common problem. The protocols are viewed in terms of higher layers, lower layers. Lower layer concerned with moving data and provide services to upper layer. So this is a scenario how a protocol is being implemented. One person is calling to the another person asking where is the cave. So this is a common protocol suite are set of rules that work together to help solve a common problem. Then evolution of protocol suites. There are several protocol suites like TCP/IP, as I said, Internet Protocol Suite or TCP/IP, OSI, Open Systems Interconnection Protocols, AppleTalk, Novel Netware. So these are the commonly used several protocol suites. TCP/IP, the most common protocol suite and maintained by the Internet Engineering Task Force, IETF. OSI, developed by International Organization for Standardization, ISO, and International Telecommunications Union, ITU. AppleTalk, proprietary suite released by Apple Inc. Novel Netware, proprietary suite developed by Novel Inc. So there are in TCP/IP there are basically 4 layers: application, transport, internet, network access. Whereas in OSI there are 7 layers. TCP/IP layer. TCP/IP consists HTTP, DNS, DSCP, FTP in application layer. Transport layer consists TCP, UDP. Internet layer consists IP4, IPv6, ICMP version 4, ICMP version 6. Network access layer consists of Ethernet, ARP, WLAN, like ISO, AppleTalk, Novelware. These are the other protocols, commonly used protocols which are present. TCP/IP protocol example. This is an example given. TCP/IP protocol operate at the application, transport, and internet layers. The most common network access layer LAN protocols are Ethernet and WLAN, wireless LAN. Web server is interacting with the client. Layer name: application, transport, internet, network access. Application layer consists of HTTP. Transport layer consists of TCP. Internet layer consists of IP. Network access layer consists of Ethernet. TCP/IP protocol suite. This is the complete illustration of the TCP/IP protocol suite. It is showing different protocols involved in each layer. Application layer consists of DNS, DSCP version 4, DSCP version 6, SLAC, SMTP, POP3, IMAP, FTP, SFTP, TFTP, HTTP, HTTPS, REST. Transport layers consist of connection-oriented TCP, connection-less UDP. Connection-oriented means there is connection. In connection-oriented, we got the acknowledgement after sending the data packet from sender to receiver. Whereas connection-less, we don't get any kind of acknowledgement after sending the data packet from sender to receiver. Internet layer consists of IP4, IPv6, NAT, messaging, ICMP version 4, ICMP version 6, ICMP version 6 ND. Routing protocols consist of OSPF, GRP, BGP in internet layer. Network access layer consists of address resolution protocol like ARP, RARP also another protocol also present here. Data link protocols like Ethernet, WLAN. TCP/IP communication process: a web server encapsulating and sending a web page to client. It is the process through TCP/IP communication process happens, like data, TCP, IP, Ethernet, user data, TCP segment, IP packet, Ethernet frame. A client decapsulating the web page for the web browser, user data, TCP segment, IP packet, Ethernet frame. Like web server, web client is sending these data packets, data, TCP, IP, Ethernet. It is going like this. This is the scenario how it is going in the form zeros and ones. Standards organizations. What are the different standard organizations are there in networking? IEEE, IETF, IANA, ICANN, ITU, TIA. Open standard encourage interoperability, competition, innovation. Standard organizations are vendor neutral, non-profit organizations established to develop and promote the concept of open standards. Standard organization, Internet standards. Internet Society, ISOC, Internet Architecture Board, IAB, Internet Engineering Task Force, IETF, Internet Engineering Task Force, IRTF. So these are the different organizations which are different Internet standards bodies: Internet Society, Internet Architecture Board, IAB, Internet Engineering Task Force, IETF, and Internet Research Task Force, IRTF. IETF consists of IESG, Working Group 1, Working Group 2, then Research Group 1, Research Group 2. Next, this Internet standards. Internet Corporation for Assigning Names and Numbers, ICANN, and Internet Assigned Numbers Authority, IANA. Where ICANN coordinates IP address allocation, the management of domain names, and assignment of other information, whereas IANA oversees and manages IP address allocation, domain name management, protocol identifiers for ICANN. Electronic Communication and Standards, IEEE, pronounced IEEE, dedicated to creating standards in power and energy, healthcare, telecommunication, networking. EIA, Electronic Industry Alliance, develops standard relating to electrical wiring, connectors, and 19-inch racks used to mount networking equipment. EIA, Telecommunication Industry Association, develops communication standard in radio equipment, cellular towers, voice over IP, VoIP devices, satellite communication, and many more. ITU, International Telecommunication Union Telecommunication Standardization Sector, ITU defines standard of video compression, Internet Protocol television, IPTV, broadband communication such as digital subscriber line, DSL. Reference models. As I told, OSA reference model consists of 7 layers: application, presentation, session, transport, network, data link, physical. And whereas TCP/IP reference model consists of 4 layers: application, transport, internet, network. The benefit of using layered model. What are the benefits? Assist in protocol design, because protocols that operate at a specific layer have defined information that can open and define in interface to the layers above and below it. Booster competition, because products from different vendors can work together. Prevent technology and capability changes in one layer from affecting other layers above and below. Provide a common language to describe networking functions and capabilities. So the OSA reference model consists of 7 layers. Application layer, it contains protocol that used to process communication. Presentation layer provides a common representation of data transferred between application layer services. Session layer provides services to the presentation layer and to manage data exchanges. Transport layer defines services to segment, transfer, and reassemble the data for individual communication purpose. Network layer provides services to exchange the individual pieces of data over the network. Data link describes the method for exchanging data frames over a common media. Whereas physical, the last one, describes the means to activate, maintain, and deactivate physical connections. TCP/IP reference model consists of 4 layers. Application layer represents the data to the user plus encoding and digital dialogue control. Dialogue control. Transport layer support communication between various devices across diverse networks. Internet layer determines the best path through which the network data can transfer. Network access control the hardware devices and media that make up the network. So these are the reference model, OSI reference model and TCP/IP reference model. Data encapsulation. Data encapsulation, segmenting messages. Segmenting is the process of breaking up message into smaller chunks. Multiplexing is the process of taking multiple streams of segmented data and interleaving them together. Segmenting messages has two primary benefits: increase speed, increase efficiency. Next, sequencing. Sequencing message means we need to sequencing message is the process of numbering the message so that the message may be reassembled at the destination. TCP is responsible for sequencing the individual message, whereas in case of UDP, there is no message sequencing happens. Protocol data units. Encapsulation is the process where protocols and their information to the data. At each stage of the process, a PDU or protocol data unit has a different name to reflect its new functions. There is no universal naming convention for PDUs in the course. The PDUs are named according to the protocols of TCP/IP suite. PDU passing down the stack are as follows: data, segment, packet, frame, bit. Like here it is showing. First one data, next segment, packet, frame, bits. Encapsulation examples. This is the encapsulation example and decapsulation example. In encapsulation, what things happen? Encapsulation is the top-down process, whereas decapsulation is the data is decapsulated as it moves the stack and it received as the bits, frame, packet, segment, then data. Data access. In data access addresses, network layer source and destination addresses responsible for delivering the IP packet from original source to final destination. Data link layer source and destination addresses responsible for delivering the data link frame from one network card NIC to another network card NIC on the same network. Layer 3 logical addresses. In layer 3 logical addresses, source IP and destination IP is involved. The IP address of sending device original source of packet happens in source IP address. Destination IP address consists of the IP address of the receiving device, final destination packet, destination of the packet. IPv4 and IPv6. The leftmost part of the network addresses indicates the network group, which is the IP address is a member, whereas the host portion of IPv4 or interface ID IPv6, the remaining part of the address identifies the specific device within the group. This portion is unique for each device on the network. So this is showing how IPv4 and IPv6 is basically working. Devices on the same network, devices on a remote network. So these are the examples. I am overcoming those examples. So MAC address, media access control addressing for the first segment is source destination. So media access control address it is showing. So this is the examples. We can implement it in Wireshark. Wireshark is a tool where we can see the networking protocols, how it is working, and we can capture them also by using Wireshark. So this is for today's session. I hope everyone has enjoyed this session. Thank you for listening this session. Thank you.